Okay, so this unit, we talked about counting, specifically permutations and combinations, and sort of how to use them to solve situations where you're counting the number of something that's happening, or counting the number of objects or that you can make out of something along those lines. This one is, this last lesson is really just an algebra lesson, that we can do a certain type of algebra knowing the combinations formula, okay? And that type of algebra deals with binomials, specifically taking a binomial, two terms, and raising it to some exponent. So let's follow a pattern, and we're going to see a pattern comes out of this. What is a plus b all to the 0? 1. What is a plus b raised to the first? Itself. A plus b. Now, I'm just going to put in the coefficients, and you'll see why in a second. And I'm also going to put in the exponents, starting here. So yeah, we would do a plus b. Technically, if we wrote the coefficients and exponents, it'd be 1a to the first plus 1b to the first. So this one means do a plus b times a plus b. So a plus b times a plus b that's 4 multiplications. So a squared plus ab plus another ab plus b squared. Which simplifies to a squared plus 2ab plus b squared. So we wrote that, and you'll see why I'm writing it like a triangle set. And again, if I wrote all the coefficients and all the exponents that we assume to be 1, it would look like that. Now, a lot of mathematics is about patterns. Without, like if you did a plus b cubed, you'd have to do a plus b times a plus b, which is 4 multiplications. You get this. Then you'd have to times these 3 by another binomial, which is 6 multiplications, which is getting pretty complicated. What do you think? How many terms do you think are going to be in the answer? Fine. Whoever said 4. What's that? Yeah. Like if it's 0, there's 1 term. There's 1, there's 2 terms. It's 2, there's 3 terms. So it's going to be 4 terms. What do you think the first one is? Right? What do you think the last one is? Now it's just trying to figure out those 2 in the middle. This might be a little bit harder to see. But maybe if we do this one, you'll be able to see the pattern even better for the next one. So what you would get is 3a squared b to the first plus 3a to the first b squared. How many terms do you think this will have? 5. And the one at the beginning is going to be 1a to the 4th, and the one at the end is going to be 1b to, 1b to the 4th. Any ideas? A to the 3. Yes. How did you get that? There's a couple ways you can look at it. If you look at this diagonal, okay? Or if you look at this. For the inside terms, not the ones on the outside, it's always the two above the coefficients added together. So 1 plus 3 gives me 4. Notice the exponent for A goes down by 1, and then the exponent for B starts up at 1. So what do you think the next one would be? 4? You sure it's 4? I think you're thinking this one. Sorry? 6. Why? Because 3 plus 3. A squared, B squared. And then 4A 1, B 3. Good. So we can follow this pattern one more time. So this is going to have 6 terms. This 5 A to the 4th, this goes down, B to the 1, plus 10 A to the 3, B squared, plus 10 again, A squared, B, and then plus 5 A to the 1st, B to the 4th. Okay. So there's a bunch of different patterns going on here, actually. So what do we see when we look at all this? The number of terms is one more than the exponent of the binomial. So if you're raising something to the 7th, how many terms are going to be in the answer? 8. One more. Okay. The sum of the exponents in every term, if we pick one of them, is equal to the exponent of the binomial. Like if you look at all of these, 3, 3, 3, 3. Same as here. And then here it would be 4, 4, 4, 4, 4, and so on. The exponent of the first term, which we call A, okay, technically, or sorry, begins with the same exponents as the exponent of the binomial, and then it decreases by 1 every time we go to the next term. So if we're raising A to the 5th, first term has an A to the 5th, second has an a to the fourth, a to the third, until you get to the end where it doesn't even have an a. Okay. The b's, technically, it's 0 in the first term. Because anything to the 0 is 1. So you could think of this like 1a to the fourth, b to the 0, if you wanted to. And it increases by 1 for each successive term until it gets to the end where it matches the exponent of the binomial. So knowing that, what would x plus y to the sixth be? Now, notice we're using different variables. So all we have to do is change the variables. What's the first term going to be? 1x, yeah, 1x to the sixth. I mean, technically, you don't have to write the 1, but you may want to, just so you can remember the pattern. I mean, as far as I'm concerned, this is the same as x to the sixth. Plus 6x to the fifth. Yes. 6x to the fifth. Y to the first. Plus. Remember, we're here now. So it'd be 15 x to the fourth, y squared. Then plus 20 x to the third, keep going down by 1 on the x's, keep going up by 1 on the y's, maintaining a sum of 6. And then we get 15 again, x squared. Wait a minute. X squared, yes, y to the fourth. Check myself there. Plus 6, x to the first, y to the fifth, plus 1, y to the sixth. The exponents are pretty easy to see, but the numbers, okay? I mean, the only problem with the numbers now is if we did something, say, if I asked you what's x plus y to the 10th, you'd have to say to me, oh, well, then I got to figure out what are the numbers when it's to the 7th? What are the numbers when it's to the 8th? What are the numbers when it's to the 9th? And then follow that pattern. That's not very efficient. Fortunately, the coefficients can be found by using combinations, where n is the exponent of the binomial, and then you start at 0 and count up until you get to the exponent of the binomial. So 6 choose 0 is 1. 6 choose 1 is 6. I mean, how many ways can you choose one number from 6? 6 ways. 6 choose 2 works out to 15. 6 choose 3 works out to 20. Remember I said there was a relationship between 6 choose 2 and 6 choose 4? If the two numbers at the end added up to the number at the beginning, they're the same answer. And 6 and 1. So that's actually a quicker way. So like if I wanted to find the third term of x plus y to the 10th, I'd go 10, choose 2. That would tell me the coefficient. Because this is 10, same as the exponents, and the third one represents 2. Notice it's 1 less. And finally, before we jump into a formula, okay, all these coefficients that we did, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, where the pattern follows that pattern follows. Okay, how do you get that number? You add the previous two above it. That's known as Pascal's triangle. And there have been questions occasionally where you've been given, say, one row of the triangle and asked to find the next one. So you do have to remember how to get the numbers. Okay. All right. How do we find everything? Like, how do we find a specific term number? Okay. Here's a formula that you get. So if we have some some term called A, some term called B, and we're raising it to the N. If I want to find a certain term number, okay, I use K plus 1, where K equals 0 represents the first term. K equals 1 represents the second term. K equals, do you have to go? Okay. This is going to be boring for you, though. Yeah, don't answer. K equals 2 is the third term. And N represents the exponent of the binomial. So here's how we could do it. Like, let's say we have x minus y to the fourth. How many terms are there going to be? 5 terms, right? So how would I calculate the first term? Well, K would be 0. And N would be 4. Okay, to find K, you just take the term number minus 1. So the first term number, which we'll call T1, equals to get the coefficient, it's 4 choose 0, which is going to be 1. To get the x part of the term, it's x to the 4 minus 0. Here's where you got to be careful. This one, B, is negative y, right? Because it's minus y. So it's negative y to the k, which is 4. 0. Wait. Yes, 0. What am I doing? And actually, I'm thinking of, here, let me do this. X to the 4 minus 0, negative y to the 0. There. Yeah. It's important to put the parentheses up. So that's the first term. Then we would do the second term. So for the second term, K is what? 1. N is still 4. So for the second term, I do 4 choose 1 times x raised to the 4 minus 1 times negative y raised to the 1. That's what I'm trying to squish it all in here. The next one, T3, term 3, K is equal to 2, N is equal to still 4. 4 choose 2. And then x raised to the 4 minus 2, negative y raised to the 2. And finally, because there's only going to be 4 terms, the fourth term, k is equal to 3, n space is 4. It's going to be 4 choose 3 times x to the 4 minus 3 times negative y to the 3rd. Wait a minute. There's 5 terms. Pardon me. All right, I'll have to add it down here. C5. Because I have to, I have to run out n, or I have to run out k. So in this one, k is equal to 4, n is equal to 4. So we get 4 choose 4. And then x to the 4 minus 4. And then negative y to the 4. This is pretty long, but I just wanted to show you how we calculate each term. What you're going to basically be asked is the ones on the next page, okay? Where you're given something and you're asked to find, say, the 6th term. So let's simplify this. 4 choose 0 is 1. X to the 4 minus 0 is x to the 4th. Negative y to the 0 is just 1, because the negative's in parentheses. So, and then this times 1 is just the same thing, right? So I really don't need this. Because that's just the same as times 1. Plus 4 choose 1 is 4. X to the 4 minus 1 is x to the 3rd. Negative y to the 1st is negative y, isn't it? So what do I have to do here? I'm going to change this to minus and then put the y in there. Because you wouldn't write it 4x to the 3rd, negative y to the 1st. That doesn't make sense. You're confusing it with subtraction. So if one of these becomes negative, you're going to have to change the sign. This one, 4 choose 2, is, what is it again? 6? No, 6? Yes. Well, 6. This is x squared. Negative y all squared becomes positive y squared. Next one, 4 choose 2. Sorry, 4 choose 3 is the same as 4 choose 1, which is 4. Notice I'm not putting the sign yet because it's going to become negative. Four choose 3, and then I got x to the 4 minus 3, which is x to the 1st. And then I've got negative y to the 3rd, so the negative's got to go here, and then I put y to the 3rd there. And then finally, and this is going to be plus, 4 choose 4 is 1, x to the 4 minus 4 is x to the 0, which is x to the 1, which is basically, we can just take it out. Negative y all to the 4th becomes positive y to the 4th. Okay. Like I said, you would not be asked to do all of this in a question. you would be asked to find a specific term number. So the more realistic questions would be ones like example 3 and example 4a. Actually, 4a and 4b. So let's look at these. Because notice they're starting to get a little bit more complex. So just remember, let's n is 7. A, the first term, is 2x, and b, the second term, is 5 when we use our formula. When we find the fifth term, what's the value of k? Remember, k plus 1 is 5. Fifth, k is equal to 4. And now you plug all of that into your formula and simplify. Okay, so we're going to have, for the fifth term, g of 5. For the coefficients, it's n, 7, choose k, which is 4. Here, we're going to have the value of a, which is 2x, raised to the n minus k. Remember, you've got this formula, so you don't have to remember all of this. Times whatever the b term is, which is 5, raised to the fourth, or k. And now we have to simplify this. This is obviously a calculator section question. So 7 choose 4. Leaves us 35. Two x to the 7 minus 4 is the same as 2x to the third. Sorry, 2x. Two x to the third. You got to be careful with that. Okay. And then, well, 5 to the fourth is going to be a number, isn't it? So 5 to the fourth actually gives us 625. What is 2x all to the third? This is where you got to be careful. Remember, I got to raise everything inside to the third. What is 2 to the third? So it's 8x to the third. Times 625. So it's going to be a really big number, and it's only going to have an x. So 35 times 8 times 625 gives us 175,000. X to the third. That's the final answer. Okay. So remember, when you're asked to find a term number, get n, get k, get the value of a, or get the expression for a, get the expression for b. Watch out for the negatives. And there is some work required in simplifying. So before I do b for each one, let's do a for each one. Find the fourth term. Okay, what's n?
4.
4. What's k?
3.
3. What's a? 2x. What's y?
-1.
Minus y. And then it's a matter of using your formula to plug it in. So to find the fourth term, it's n choose k, 4 choose 3. 2x to the n minus k, or 4 minus 3. Negative y in parentheses to the fourth. And now 4 choose 3 is the same as 4 choose 1, so it's 4. Times 2x to the first times what? Negative y? If I raise negative y to the fourth, isn't that negative y times negative y times negative y times negative y? Doesn't it become positive?
No, it's all from 3 up.
What?
It's 3.
What did I do?
We start with simplest. We're going to have all 3.
Why is it negative? Oh, because it's ah. Thank you. Sorry. So yes, negative y to the third. And 2x to the first is just the same as 2x, right?
Yeah.
Okay. How would you write your final answer? When I multiply all these together. Negative 8 x, or x to the first, y cubed. And I ran over into the other question, but I have to erase it out. Okay. This next one. What's a little weird about this one?
It's a fraction.
Yeah, there's a fraction. How can I write that without a fraction? When we had fractions and we were working with exponents, what did we discover about the exponents?
Negative.
They were negative, right? So this is the same as 2x to the negative second. You can just bring the x squared up with the 2, and because you've taken its reciprocal, it goes from positive to negative in terms of exponent. So to find the fifth term, n is 10 here. K is
It's 4.
4.
Is x to the third.
A is x to the third, and b is 2x to the negative second.
2x.
Because there's a 2 here. So x, 1 over x, this is the same as 2. Yes? This is the same as x to the negative 2. So it's the same as 2 times x to the negative 2. Yeah. Okay, so the fifth term, T5. 10, choose 4. That's going to be a big number. X to the third to the n minus k, or 10 minus 4. Times 2x to the negative second to the fourth. You should be able to get there because that's just plugging in using the formula. Now I'm going to use the calculator. 10 choose 4 gives you 210. This simplifies to x to the third to the sixth. Whoa. Wait. Let's go to the next step. What is x to the third to the sixth?
Nine.
X to the, when I raise one power to another power, what do I do with the exponents? X to the 18th, I multiply. Times, and I'm going to put this in parentheses because I'm going to get a number, 2 to the fourth. Boo. 16. X to the -8. Now I got to multiply the numbers, 210 times 16, and I get 3360. What's x to the 18th times x to the -8? X to the 10, because we add the exponents, right? So it's 18 plus -8, which is 10. Okay, the last type of question you can see is, oh, sorry, that was very anticlimactic. Because this isn't this type, this is still a finding the term. What's the middle term? How many terms are there?
3. Okay, I'll start 4. 5.
There's 5 terms. Okay, the number of terms is always one more. So doesn't that mean that the third one has to be in the middle? So we're finding T3. And because we're finding T3, K is 2, N goes back to 4, A is equal to 2x, B is equal to -y. So therefore, T of 3 is going to be 4 choose 2, 2x to the n minus k, 4 minus 2, -y to the k, or 2. Four choose 2 is the same as 6. This is the same as 2x squared. -y squared is the same as positive y squared. That's 6. What's 2x all squared? 4x squared times y squared. And that gives me 24 x squared y squared. Okay, now the other type of question you may see. There's always a very good chance of seeing the type of question that we just did, where you're asked to find a certain term. But sometimes this creeps in. You're told part of the term number, you're asked to find the term. That's crazy. Well, first of all, remember, the term number equals k plus 1. K plus 1.
Hi, I'm trying to see where the T what?
T hashtag. Term number. Okay. So what are we trying to find? We need to find k. And then once we find k, we need to add 1 to it to get the term number. So it's k that's unknown, which means that we know n. Well, it's 10. We know a,
it's x to the third. And we know b, it's 2x to the negative second.
So if we use our formula
to find t of k plus 1,
I have to do
n choose k. In other words, n is 10, choose k, because we don't know that. And then it's x to the third times n minus k. Well, we know n is 10,
but we don't know k.
Finally, 2x to the negative second raised to the k.
Before I go any further, this is going to give me a number, isn't it? Right? Like whenever I find k, this is going to give me some number. I don't care what the number is in front. I only care about finding k. Because we're not asked to find, we're asked to find which term number contains this exponent. We're not asked for the coefficient. So anything that produces a coefficient, get rid of it because we don't need it. Okay? So what happens then,
When I take all this out, this actually changes to x to the 15th is equal to x to the third raised to the 10 minus k, x to the negative second raised to the k.
that's an exponential equation.
We need to write all of this
As a single power of x.
by using our exponent laws. When I raise one power to another power, what do I do? So this is the same as x to the 3 times 10, which is 30, minus 3 times k, which is minus 3k. This is the same as x to the minus 2k. I can keep simplifying this side. When I multiply two exponents, what do I do with the exponents? Or sorry, when I multiply two powers, what do I do with the exponents? Add them. So it's going to be 30 minus 3k plus minus 2k, which is the same as 30 minus 5k. Finally, remember, we're trying to solve for k, right? So can't I cancel those out? And I'm left with 15 equals 30 minus 5k. We need to solve that. So I'll keep the k on this side, subtract 30, gives me negative 15 is equal to negative 5k. Therefore, k is equal to 3.
But that's not the term number.
The term number is, if k is 3,
What's the term number? 4. Term number 4. That's a pretty heavy one. Okay. So heavy, we're going to try another one.
I know, good for you. Let's go. Hey, Kara.
I figured you'd like that. How about this one?
So we've got x plus 1 over 2x to the 7. We have to find which term number contains x to the third. So we need to find k. And then to get the term number, we add 1. What's n? 7. Now, we got a fraction here. What's that? No, I can't move the 2 up. Like this is 1/2. This is the same as 1/2 times, this is the same as 1/2 times 1 over x. Only this changes to a negative exponent. So it becomes 1/2 x to the negative first. Yeah, that's because remember, the exponent attached to the variable is 1, but it's attached to the x, not the 2. Okay? So a would be 1/2 x to the negative first. And sorry, a would be x. And b would be 1/2 x to the negative first. All right, so t of k plus 1 equals 7 choose k times x to the n minus k, or 7 minus k, times 1/2 x to the negative 1 to the k. Remember, the coefficients don't matter. Anything that I only care about the x's. That's not going to have an x in it, so that's irrelevant. Same with this. That's irrelevant. So I'm only focusing on these, and these are going to equal x to the third. So that means I get x to the 7 minus k times x to the minus k. Now I have to add these two. What is 7 minus k plus another k? Sorry, plus another negative k. 7 minus 2k. Those go. 3 equals 7 minus 2k. Negative 4 is equal to negative 2k. K is equal to 2. Therefore, the term number is 3. There is a way to sort of check this stuff. If you get a negative, something's gone wrong. If you get a decimal or a fraction, something's gone wrong. Because remember, a term number has to be a whole number. Okay? So in a way, you can kind of check to see if your answer makes sense. Okay.